Hello everyone and welcome back to Math Merit. Today we are going to learn how to identify a graph or a table for an inverse variation and whether a graph is for an inverse variation or a direct variation. Okay, so these are our two options. One is inverse and one is not. One is direct. Okay, so this one right here is a table that has been graphed for a direct variation. Okay? Looks like our regular graph. Now, for an inverse variation, you will see that it does not cross the y-axis where x is to equal 0. Okay, now remember, up and down is our y-axis, side to side is our x-axis. Now where x is supposed to equal 0 is right here. Okay, right where I made that dot. Now here along this line you will see that our lines do not cross. Now let's see what a table would look like for an inverse variation, which will give it away pretty easily too. Now this is an example of a table. For our x values, we have -8, -4, -2, -1, 0, 1, 2, 4, and 8, giving us y values of -1, -2, -4, -8, undefined, where x equals 0, undefined, 8, 4, 2, and 1. So when x is given the value of 0, there is no, it can't be defined as to where the y will land or where it would cross. So pretty much our lines then just swoop up or swoop down. They're either positive or negative. Okay? So that is how you identify whether it is an inverse variation or a direct variation. Now put up some graphs and tables on the board for you to tell me. Actually, before we go into that, I did miss a step. I need you guys to include this into your notes. Okay? Now pay attention to what I'm telling you, and this will give you very important details. So where you have your equation that's y equals k times x, and k is greater than, that's what this means, greater than 0, this is what your direct variation will look like, okay? When k is greater than 0. Okay, now what if k were less than 0? In this case, our direct variation would look like this, which is in the opposite direction. Okay, so when k is less than 0, this is what our direct variation would look like. But see the reasons why when it is a direct variation. Look at the things you are looking for. Y varies directly with x. Now, the easiest one in the book and how you can actually identify it is when you do the ratio of y over x, and in each part of the table it comes out the same number and it's constant. That means you are dealing with a direct variation. Okay, so that is important for today. And one more thing. Now, inverse variations. We have y varies inversely with x. Y is inversely proportional to x. The product. Now, it's not the ratio. We're not dividing anymore. We are multiplying product. Remember, product means multiplication. The product of x and y is constant. Okay? So when it's a ratio that is constant, that is when we're looking at a direct variation. Now, when it is the product, which is in multiplication, and it's constant, that is inverse variation. Now, it'll look a little differently as well. You would have y equals k over x. When k is greater than 0, our inverse variation would look like this, where we have our lower left quadrant and our upper right quadrant filled. Okay? Now, if k were less than 0, it would be just the opposite. Our upper left and our lower right would be filled. Okay? Now, this is for k, when k is less than 0. For your assignment today, I have these 4 graphs. Tell me which graph is a direct variation and which one is an inverse variation. Now, you're not just going to tell me whether it's direct or inverse. When you tell me whether it's direct or inverse, I want you to also tell me whether k is greater than 0 or k is less than 0. Make sure you look back at your notes. If you have any questions on anything, please don't hesitate and ask. I'm here to help. I hope you all have a very wonderful rest of your day, and I hope to be hearing back from everyone very, very soon. Goodbye.